Day 19, we're going to review some of the main ideas from this part 3 of the quadratics unit. So warm up. Atom has an initial vertical velocity of 20 feet per second and a release height of 6 feet. Write the equation that represents the height of his ball over time if gravity has a downward acceleration of negative 16 feet per second squared. So I'm going to underline the important information. We have this initial vertical velocity, and we have this downward acceleration, and he has also a release height of 6 feet. And if you've looked at the basketball section when we studied the path of the ball over time, we know that the equation can be represented by this. I'll say h of t, which is just his height over time. You could say y equals as well. And so first we start with the downward acceleration, and that's that negative 16 feet per second squared. All right, so it's negative 16t squared. Next came the initial vertical velocity, and that was 20 feet per second. So plus 20t. And then the c value was always the release height, and here the release height is 6 feet, so plus 6. If we plug in a 0, so that would be at time 0, we can see that the first part of the equation would turn into 0, and you would get the release height of 6 feet. All right, so here's the equation. So far this week we have looked at the following topics, and we're going to review those today before the upcoming test. So you should know how to find the vertex, the lowest or highest point, how to change from factored form to standard form, which is also called general form, how to change from vertex form to standard form, and we also looked at the basketball application of quadratics. So our goal today is to review those ideas here, and then if you have additional questions, you can let me know during office hours before your test, which is coming up very soon. All right, so let's take a look at the first thing. How do we find the vertex? So it says find the time when Atom's ball will reach its maximum point. And so if you think about throwing the basketball, so we have, here's Atom. He has this release height of 6 feet, so let's say that's right here. And we know that that ball is going to go up and then down. Hopefully it's going to hit the basketball hoop. So if we draw that. Okay, so here's the 6 feet right here. We're looking for the vertex. When does it reach its highest point? So the time when it reaches its highest point. And to do that, that's the vertex. It's the x value of the vertex. It's x equals opposite b over 2a. So we just have to identify what a and b are. So if you take a look at our equation, which is in general or standard form, there's no parentheses here, the a value, and we've been doing this since the beginning part of quadratics, is the number in front of the x squared, in this case t squared. So here's a, the negative 16. The b is the number in front of the x, in this case the t, so the b is 20, and then c is the number by itself, and so c is 6. All right, so let's plug into b and a to find the time when Atom's ball reaches its highest point. So we have opposite b, so opposite 20 is negative 20, over 2 times a, 2 times negative 16. And if we multiply that out, that's negative 20 over negative 32. So I'll do that in my calculator here. And we get 0.625 seconds. All right, so after 0.625 seconds, a little over half a second, that ball will reach its maximum height. Okay, so that's the time, the x value. Now the second question says, at what height is his maximum height? Find the height at Atom's ball at that time. And so to find the height, that is the y value, in this case h of t. And so we're going to plug in 0.625 for t, or for x, whatever you prefer. All right, so I'm just going to say y equals, even though it's h of t equals. So y equals, and we're just going to plug in, every time I see a t, I'm going to plug in 0.625. So times 0.625, and it's squared, plus 20 times 0.625, and plus 6. And since everything on the right-hand side of the equation are numbers, I call this plug and chug, we can just type that directly into our calculator or into whatever calculator that you're using. So I have negative 16, parentheses, and it was 0.625 going to square that, plus 20, and then again plug in the 0.625, and then it was plus 6. All right, so we plugged in the time, and this will give us the height. So after 0.625 seconds, the maximum height of the ball is 12.25 seconds. So we're going to write y equals 12.25. Oh, I said seconds. I meant feet. And that's the maximum height of the ball. So we spent a few days going over how to find the vertex, and then putting into word problems too, how to find the vertex, the time, and also the height. All right, so the next thing that we're going to cover is factored form to standard or general form. So factored form, we've looked at things in factored form. What does factored form give us? It gives us the zeros. So for example, what are the zeros or roots of this quadratic? So it's asking where does it cross the x-axis, and one of them is pretty easy here. We know one is -8. The other one, if you're not sure what makes this 0, just make an equation. 4x minus 5 equals 0. Let's find the zeros for that. So here I'm going to add 5 to each side. So we have 4x equals 5. We'll divide by 4. So x equals, and we can leave it as a fraction, or if you want the decimal, you can do that as well. And so if we were to graph that, let's see what 5/4 is. 5/4 is 1.25. So at -8, 1, 2, 3, 4, 5, 6, 7, 8. At -8, there's a 0. And at 1.25, is the other 0, and that's at 5/4, so 1.25 might be right there. If you look, the a value here is +1 because there's not a number in front, so that means it's a smiley face graph. I don't know what the vertex is in this form, but we can sketch the graph, and it might look something like that. And so again, we've practiced finding the zeros many times. Those are also called the x-intercepts, or the roots, or the solutions. All right, but what was new in this part 3 of the unit was, can you change from factored form to standard form? And so here's the original equation in factored form. 4x minus 5 and x plus 8. So to change it to standard form, you can FOIL it if you prefer FOIL, or you can put it in the rectangle. So here we have the factors which go on the outside, and we're going to get the inside of the box to find standard form. So my first box over here is 4x times x, which is 4x squared. My second box is -5 times x, which is -5x. My third box is 4x times 8x, which is 32x. And my last box is -5 times 8, which is -40. We're going to combine like terms here. The x's you can put together. So our final answer in standard form, where the highest power of x is first, is 4x squared. And then 32 minus 5 is 27, so plus 27x. And then the minus 40 goes at the end. And now you have something in standard form. I could ask you to find the zeros, and then you could plug into quadratic equation. You should easily be able to see what a, b, and c are in this form. So you will have to know how to change from factored to standard form. Okay, next we looked at vertex to standard form. I might ask you, what is the vertex of this graph? So again, we're looking at how the graphs shift from y equals x squared. So this goes back to first semester. How does the graph shift? And the +3 indicated that this goes left 3, and the -6 means it goes down 6. So the vertex of our first parent function, y equals x squared, the vertex is where it changes direction, and here it's 0, 0. But if it shifts left 3 and down 6, the new vertex will be -3, -6. So it's always the opposite of the number inside the parentheses if it's squared, and then it's the same as the number on the outside. So there's the vertex of the quadratic. I'm going to ask you, is this a minimum or a maximum? And here the a value, the number right in front of the x squared parentheses, is a +1. So that vertex would be a minimum, or the smallest value. Minimum. If I were to graph this at -3, -6, there's the vertex. I don't know what the zeros are in this form. I could convert it and find them out, but our graph would look something like that. All right, and then the new part here was, can you change from vertex form to standard form? So again, I'm going to rewrite that first equation that was in vertex form, and it was x plus 3 squared -6. Okay, and to multiply this out, we use order of operations, so we're going to start with the squared first. X plus 3 squared means x plus 3 times x plus 3. We're going to get the inside of the box. So this first box will be x squared. My next box will be 3 times x, which is 3x, and this box happens to be the same. And then our last box here is 3 times 3, which is 9. And so we have x squared plus 6x plus 9. The next step is if there was a number, an a value, in front of the parentheses, we would distribute it to these three terms, but here the number is 1, so we'll leave it x squared plus 6x plus 9. And then the last step, we'll do that minus 6 at the end right here and combine like terms. And so our final answer in standard form is y equals x squared plus 6x and then plus 3. So we'll combine the 9 minus 6, we get 3. Okay, so you'll have to know how to change from vertex to standard form. And then lastly, we've been looking at applications. So again, basketball applications. When will Adam's ball reach a height of 10 feet, which is the height of the basketball hoop? So if we go back to the Adam's problem right here, we have to know how to find the vertex, which we did. But again, here's 10 feet right here. When will it reach a height of 10 feet? And we'll get two answers, right? So it's going to hit 10 feet right away, and then it's going to hit 10 feet again, and hopefully it hits the hoop at that point because the hoop is 10 feet tall. All right. So here's that equation, Adam's original equation, negative 16 t squared plus his 20t plus 6. When does that equal 10? Now, in order to solve this quadratic, you do have to get 0 on one side, so subtract 10 first. And we have this equation, negative 16t squared plus 20t. This will be minus 4 equals 0. Now that you have 0 on one side, you could try to factor this and use zero product property, but the easier way that most people prefer is quadratic equation. So let's find a, b, and c and plug into quadratic equation. So we have negative 16 for a, 20 for b, negative 4 for c. And remember your song, x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. All right, so you plug everything in. Okay, and then I told you to minimize the error. You should get these three numbers right here. So that's what I'm going to do. So I have negative 20, plus or minus the square root, and then I'm going to type in 20 squared minus 4, parentheses, negative 16, parentheses, negative 4. Okay, so that is negative, 20 squared minus 4 times negative 16. Oh, I think I plugged in wrong, didn't I? Minus 4, 8. No, that's right. C, times. Okay, so I get 144. I typed it in wrong the first time. Let me double check. 20 squared minus 4, parentheses, negative 16, parentheses, negative 4. Okay, yep, 144. And then all over negative 32. And then from there, you get two different answers. So now I can type it in. I'll do negative 20 plus the square root of 144, which is 12. Hit enter, divide by negative 32. So one of my answers is 0.25. All right, and the other answer will be negative 20 minus the square root of 144, which is 12, divided by negative 32. And that is 1. And so the reason why we get two times, one is 0.25 seconds, and that's here. It hits 10 feet at 0.25 seconds, it reaches its maximum, goes back down, and at 1 second, it will reach the hoop. Okay, so here it says, when will it reach a height of 10 feet? Two answers here, 0.25 seconds and 1 second. It will hit the hoop, or reach a height of 10 feet. All right, and then the last question. When would Adam's ball reach the ground if he missed the hoop? Okay, so again, you have that basketball is going to go up and then down. So you're trying to find this right here, and this is the 0 of the graph. So here's the other 0, right? One will be negative because we start at a height of 6 feet. All right, so we want the 0 of the graph, and to find the 0, we can again try to factor it, but most people prefer quadratic formula, but this time we're going to use the very first equation, that negative 16t squared plus 20t plus the 6. We want to know when that equals 0. So here's the first equation, not this one where we set it equal to 10, but when it equals 0. When will the ball equal a height of 0? Again, we're going to find a, b, and c. So a is negative 16, b is 20, c is 6. Plug into quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And again, I will calculate these parts separately to minimize any mistakes. So I get negative 20 plus or minus the square root. Let me type this in. 20 squared minus 4, parentheses, negative 16, parentheses, 6 of 784 all over negative 32. We're going to type this in. We're going to get two answers. So negative 20 plus the square root of that divided by negative 32. All right, so one answer is negative 0.25, which we're not going to look at because it's negative, and the other will be negative 20 minus the square root of 784 divided by negative 32. All right, so at 1.5 seconds, that ball will reach the ground. So study this, and again, if you have questions, just email me and let me know. Stop in for office hours and we can go over this, but expect to see these types of problems coming up very soon on your Chapter 7 Part 3 test.